Now, okay, so first of all, this is a Br plus, sorry, delta plus, and this one is a delta minus. So the rich attack the poor, and then this one will break off naturally. Then this one will give you the slow step, and very quickly, the double bond will break, and the first guy that enters the alkene, who is the first guy that enters the alkene? The first atom enters alkene is Br, the one that's being attacked. So put to the carbon with more H, this part we have more H, naturally you form the more stable carbocation ion, correct? Now, why is the more stable carbocation ion more stable? Sorry, why is the tertiary carbocation ion more stable?
Because
what's the reason? Must also know. Yes, more electron donating alkyl groups. How do you continue to finish off the statement? What does it do to the positive charge? Say again? Disperse, correct. Understand? Okay, very good. Because this concept need to know for later on. Okay, so this one here, the second step, attack the carbon, very good. The plus one. So this one here is the fast step, and then you get the added product. Okay, very good. So very quickly, right, this is the first variation. Now, this is easy, but the moment I change this question a little bit to aqueous, then die. How? Yes, so not OH minus, but water, right? Okay, so not OH minus. So this one will be the attacker now. And then you after that, depending on school again, then different school different. So some, I think your school may be more accurate here like that, like OH, H plus, correct? I don't know whether your school do this way or not. Yes, right? Then you, no choice, got to break off, right? Then after that, you get a H plus and the product, correct? Okay, so this variation number 2, whereby it's the halogen, but aqueous medium, correct? Okay, got 2 more variation. What is it? Altogether got 4. We have covered 2 very quickly. What's 2 more? Electrophilic addition of what thing?
HBr.
Very good. HBr is another variation, so delta plus, delta minus, and the last variation is W. Very good, water. So water, right? What is the condition for hydration? Must say laboratory, you cannot say industrial. Industrial they can set, but you cannot propose. Cold, concentrated sulfuric acid, followed by, very good, right? So followed by H2O, okay, depending on school, and okay, it's fine. Understand? So 4 variation for electrophilic addition. Very good. So let me run through very quickly. The next key part to this part is called the oxidation, right? Okay, so oxidation for alkene got how many types? How many types? How many types of oxidation are there for alkenes? What's the reagent name that I roughly know? Okay, 2 types, which is
Strong
mild. Very good. Right. So the conditions very quickly before we try to draw something. The conditions for mild is
when TMNO4, then NaOH or here.
Okay, most of that NaOH. Okay, he also can.
Then the strong one is the same.
Finish. Must write cool. Okay. Yes. Okay. So this one normally, I mean, okay, sorry, must put dilute. Right. So H2SO4 and heat, right? Okay. So of course can also NaOH. It's just you adjust the acid. Okay, now very quickly. The mild oxidation, what is it? Very easy. Hardly come out also 10% chance.
H become
very good. Diol is formed then. Right. So this is the mild version. Right. So now the key part is the strong version. So before I continue, I will ask you to draw first. Okay. Okay, so you chop over here, right? So the rule is very simple. We don't change, we draw the shape, very good. Double bond O at the breakage part, and if it's an aldehyde, means at first there's a H here, I add an O, correct? Okay, so this is the strong oxidation. The rule is very simple. Break double bond, separate the guy at an O. Then if there's a H directly connected to that carbonyl, to that C there, then you add an OH. Now, I think level 2 question, which is tougher, is this. So try to draw this again. So now this is the difference. So let's say like that. Okay. Then I draw like that and like that. Okay. So try to strong oxidize this guy now. Same thing, chop here. Use another color, wait. So same thing, chop here and chop here. Now, so the top one, as usual, I think you got it, right? So you draw the same shape, right? Then double bond O, then OH and OH. This one is like just now, no problem. Now, must pay attention, very important. The bottom guy, you get this guy, OH, and this guy, OH, right? This guy doesn't exist because this guy is called ethane dioic acid, right? Which will further oxidize to form 2CO2 and H2O. So this is a special acid. Normally we'll stop at acid. Oxidation stops at acid. It's the last guy already. But this is a special acid and will further oxidize. Got two. Okay. Yeah. What's the other one that can further oxidize is your carbonic acid, right? So the two variation only. Must remember, two variation. So what's the other guy? Is here. That means, for example, I give you like that, then have a H and H. Okay, let's say C, I don't care. Okay, let's say that. Right? So you break here. My concern, the right side, I think you know. The left side, this is the this is H2CO3, which is called what? Carbonic acid, which is very unstable. So he will dissociate to form CO2 and H2O. So why do we know all this? Because they describe effervescence, they're hitting this. But I don't know is it the top or the bottom, these are two. Okay, so this part finished. So I think oxidation, no problem for you. Very good. Let's proceed. Then we can start some questions for alkene. Okay, the next one, how to form alkene. And we are done, eh? So easy. How to make alkene? There's only one method to make alkene. Right? There's only one way to make alkene. Start with E. Must know, because sometimes they elucidate or do synthesis, end up is the alkene as a product. There's only one way to make alkene. Start E. What's the name of the reaction? Start E. Elimination. Must know. How to form alkene? Because this part I don't know. Maybe it's the last part. That's why people don't know, or the first part, right? So remember, elimination is a big thing. Elimination is to form. The only way, no other way to form alkene. Okay. So elimination is the name of the reaction. There's only way. Okay, so this is to make alkenes. But elimination is the only way to make alkenes. But you need to know that there are two variations, which is eliminate water. Also can eliminate HX. Means what now? So I give you alcohol because water. So let's say there's an OH. So of course you need to think through it. Should I eliminate the triangle or should I eliminate triangle or should I eliminate the rectangle? How which one is more stable? It's a mixture of product. There's the triangle elimination. That means that the left side, there's also the right side. So which is more stable? Any idea? Make a guess. It's just like there's no concept there. I mean the concept is there, but it's not in A level. Yes. The rule you just gonna follow, but why like that? That's not in syllabus. Okay. So you need to know that the right side is more stable because the alkene has more R group, understand? Right? So of course, you just know it, I just accept it that way, okay? Of course, the reason you can go Google all this, I can't remember. I learned uni and forgot. So the whole idea is that if I eliminate the left side, the alkene is very bad. I show something, okay, just to show you a negative example. If I eliminate the left side, I get the double bond this way, right? The alkene has only one R group. One R group, but this guy, two R group. Okay, so same thing. If I have instead of water, I get HCl or HX anything. So same thing again, right? You can decide the triangle or you can decide the rectangle. Same thing, you get the rectangle more stable. Yeah, but the concern is what is the reagent? Yeah, so we learn now. I know it's a lot, but it's a constant process to make you remember. Okay. So let's say the first one is make water is what? Excess concentrated H2SO4 170 degrees. Okay, some school by heat. Can't remember the number 170 or heat. It doesn't matter. Either 170. So take out water, also this joker, concentrated H2SO4, but this excess and heat. Put in water just now is what? Co-concentrated H2SO4. So this part confuse a lot of students because our mind only think, hey, concentrated H2SO4 is either take away or give out, take away or put in, but actually it's both. Just the reagent a bit different. Right? Take away HX. Can remember? You just learned the halogen? Or can remember? Remember? Take away HX is what? Okay, this one must also know. Ethanolic KOH or NaOH. Okay, bits and pieces are no choice. There's a lot. So every day a little bit, then you'll be ahead. Understand? Okay, write down first. Okay. Yeah, so maybe you get a fresh piece of paper to write hybridization on. I think it's better, better. Okay, so hybridization, not tough one actually. So first of all, you already told me the trick, right? SP3, so SP2 and SP. So normally I guide student, okay, like how many things I know what I'm trying to say, but the faster way is the shape. Tetrahedral, right? Tetrahedral, right? This is a trigonal planar, and this is linear. Correct? Now, so let's start with your SP3, how to draw. So SP3 hybridization, how many orbitals are there altogether? Any idea? How many orbitals are there in SP3 hybridization? 4, correct. So you must know that one orbital, one hybrid orbital looks like this, one big lobe, one small lobe. So all the same, but just that got more or got less in the arrangement. So tetrahedral, so basically I will draw 4, right? So 1, 2, 3, and 4. Can you see? But you need to know the lobe. That means the lobe is that one on top, one below, right? Then this one got one lobe here and this one got lobe. Can you see now? So this is SP3, right? So the whole idea is that another SP3 will come. Okay, I'll show you something to understand fully. Because a lot of students still can score but cannot understand fully, then dangerous. Same 1, 2, 3, 4. Okay, I'll draw for you. Okay. So this case, right, is a CC single bond because there's a 6H, right? So very simple the 6H lah. So 1H, 2H, 3H, because it's S orbital, hydrogen. Finish. Right? Hydrogen is called S orbital. We got 1s1. Okay, so all these are head-on overlap. So everything here is all sigma bond. The first bond is always sigma, the stronger bond, head-on overlap. Sigma bond. So all these are sigma also. The hydrogen also carbon sigma. Understand? Okay, so try to draw this. So this is the sp3 first. sp2 you need to know is this way. Right? So you need to know sp2 means there is a sigma, there is a pi, correct? Now, sp2 how? Same thing, but trigonal planar. So 1, 2, 3. Another guy come. 1, 2, 3. Squeeze in the lobe. 1, 2, 3. 1, 2, 3. Okay, practice this. So these are the 3 sp2 hybrid orbitals. Then I have the unhybridized p orbital. Unhybridized p orbital. Right, the black one is your sp2 hybrid orbital. Okay lah, of course on top here is just now the sp3 hybrid orbital. So they will sigma the head on. So the head on is a sigma, and the side on is your pi. Side on, one set is 1 pi. So this is the pi orbital. Then same thing, you can draw all the S the hydrogen. You understand? Yeah. So it's always like that, right? Head on first, then being brought closer, then the pi can form on the side on. 1 sigma, 1 pi. Okay, and the final one is your sp orbital. So sp is a triple bond. Okay, so sp is like that, right? Only got 2, right? Because sp got 2 only. So there is 2, right? Then there's the lobe here in the center, the lobe. But now the difference is that there is a what? There is 2 unhybridized p orbital. So one unhybridized, one unhybridized p orbital, another unhybridized p orbital. Okay, then this one I have form the pi first. Then I need to, lucky I use different color. Also exam because you only blue pen or black pen, so you need to properly draw. So there are 2 unhybridized p orbitals, right? To side on overlap. So therefore 1 sigma bond, 2 pi bond. Yeah, okay, same thing. If you want to draw the H, also can. Right? Then it's just a circle on the left and right. So this is so there is 2 pi and 1 sigma. Sigma. Black one, 1 pi. Oh, the orange one for you to draw. So the orange one, another pi. Okay, so remember the shape and how my practice, no choice. So the rule is very simple. Here, I write the little rule, the rule to follow. So hybridized orbitals can only head on overlap. Okay, don't tell me hybridized orbitals side on, right? And then unhybridized p orbitals side on overlap. That's it. Okay, just that. Very good. Okay, so first of all, you need to know there are 4 electrophiles. Just know there are only 4 electrophiles you need to know, right? These are the 4 electrophiles, the 4 variation. Okay, later on you have later on you will know, or maybe you know that this tree is very similar. Okay, so nitration, this guy over here, the first step is called generation. Generation of electrophile, generation of electrophile. So for this situation, the electrophile is your NO2, the plus is on the end because the end will be attached to benzene ring. Okay, try to remember the conditions and the how to write the equation. This is the toughest. So the condition of nitration is what? Concentrated HNO3, right? Concentrated H2SO4. Okay. Because there's a methyl group, now it's at 30 degrees. If there's no methyl group, it's 55 degrees Celsius. So before this, I haven't. Why with the presence of a methyl group, I need a lower temperature only. Without a methyl group, it's 55. That means if I do nitration with a botak benzene, right, I substitute the NO2 in 55 degrees. But with a methyl group, now we are solving a methyl group, it's at 30. So the methyl group makes the benzene ring more or less reactive. More reactive. So this guy, if you check data booklet, now your syllabus can check data booklet. Last time my time cannot. This guy is it activates the benzene ring. Everything in the data booklet. Know which page? No, there's a page for it. Because, answer me, is it electron withdrawing or donating? Very good. Okay, because this guy is a electron donating. Okay, so now the headache is the equation for this, which is a big problem for a lot of students. H2SO4 plus HNO3 double arrow. Your job is to get the electrophile. So write it down first. Okay, NO2 plus is there. You do everything, no NO2 plus, then you waste your time. Now, this part is very irritating. How I learned as a student is that the stronger acid is your sulfuric acid, H2SO4. So it acts as an acid first, giving out 1H. You need to memorize the number 2 in front of them. And to balance charge, you need to add H3O plus. Okay, I'm going to pause here. This part here, please try to remember. I repeat again. Right, you put the catalyst, sulfuric acid concentrate is the catalyst to get NO2 plus, and that is a stronger acid. This is how I learned, and I remember number 2 lah. Then left side total charge 0, right side total charge must be 0. So I add in the H3O plus there to balance it, the charge. Okay, so this is the first step to get your NO2 plus, right? So this is the key part, the electrophile. Now the attack is like that, show you. So the next step, right? Number 2 will be okay, different school write different title, right? So I will just write my understanding. So attack electrophile by benzene. Some school write the other way, right? Some school write benzene is attacked by electrophile. I prefer this way because it's really the rich attack the poor, right? So now, so I draw this out. Careful, try to understand. Plus your NO2 plus. So rich attack poor. Wow, NO2 plus very desperate. A lot of electron attack this guy. Okay, right, the slow step. And because of this, problem already. 2, 4 directing. So I just here, H, here, NO2, and here, benzene cannot form so many bonds. So I angle the plus to point there, understand? This is a very unstable carbocation ion. This is a very unstable carbocation ion. This is unstable because you know why? Benzene ring disrupted, right? Okay, so it's unstable. And the last step of all is your regeneration of catalyst and benzene ring. Okay, so same thing, different school write different title, but the idea is the same. School. So now like that. Plus CH3. This is H. This is NO2. Okay. So plus your HSO4 minus. I need to regenerate him. It's fast. Okay. Different school different. Some must draw the attack, but nowadays they just draw like that. Your school just draw like that. Double check. Some school put the double dot and attack the H. Pending. Okay. Right. Nice. You get the final product, the benzene ring regenerated. Objective 1, finish. The catalyst regenerated. Objective 2, finish. This is the whole mechanism. Everything is the same one. Oh, sorry. Only the step 1 varies, which I will guide you in a while. Right? Step 2 and 3 is standard. Attack after regenerate. Attack, regenerate is the step 1 that changes. Okay? Come try to understand this for a while. So the variation is the generation. Step 1 got variation. So I told you nitration already done. So nitration I already gone through. Now, so the next one is your halogen. So Cl2 plus AlCl3, right? Give you AlCl4 minus and Cl plus. CH3Cl plus AlCl3 give you AlCl4 minus and CH3 plus. So the concern is your electrophile, right? You need to generate this, the plus guy. Right? And the last variation is what? COCl is south chloride. This one R can be. So this part also can be R, anything, not only CH3. Same. So difficult. Right, so we got 4 variation. 1, 2, 3, 4. Right, first one is written on top, NO2 plus. Two, three, four, same, right? Okay, so you must visualize 2, 3, 4, same, right? This is very summarized in your for the notes, right? Then you can just do question here. Focus is to do question at home. My job is to teach you like that, then go move on.